Okay, so let's see now, how can we charge an electroscope uh, using induction and grounding. Now let's clarify here, as the very first thing, uh, what is grounding? Grounding, it serves as a bridge for the electrons to either go into the electroscope or away from the electroscope. So let's suppose that we start with an electroscope that is neutral. So when we have a neutral electroscope, that means that the two golden leaves of the electroscope are parallel to each other. And when we have a neutral electroscope, the distribution on the knob and on the leaves is the same, meaning that as much as negatives are positives. And then here the same thing, as much as positive are negatives. Positive, negative, positive, negative, positive, negative. Okay, so this is how we started. Now what do we do is, well, we place a rod here. So the second step will be that the electroscope now is with a rod, like a charged rod here. And I will say that is negative. So negatively charged rod. So what do we notice here? A redistribution of charges is happening. So in the leaves now, we will notice a presence of the charge. Why is this happening here? Because the electrons are pushed to the electrons are pushed to the node. Okay, so now in the node, what we have is we have more negatives than positives. So negative, negative, positive, positive. Something like this. Leaving this mostly positive. And then one or two negatives. Okay, positive, positive. Okay, so since the two leaves are positively charged, like charged, they will repel each other. So we notice that the two leaves are charged by distribution of the charges, and then the node itself is mostly negatively charged. So if this is step one, where we start with a neutral electroscope, this will be step two, where nearby the electroscope we place a negatively charged rod. We are not touching the leaves, and then the distribution of the electrons is happening. And then what do is we apply grounding. So grounding is as simple as touching the electroscope with your hands. Okay, keeping the rod, the negatively charged rod here. So what we do is grounding. So if you touch the knob of the electroscope with your finger, then what you're doing is you are applying grounding. So what is happening now? The electrons that were excess on the knob have now a way to move away from the object. So they are excess, so they move away from the object. Electrons are leaving, they are flowing away from the electroscope. They are flowing out from the electroscope. And then as the fourth step, still keeping the rod into the electroscope, we take away grounding. So what will happen on this case? Remember what grounding was doing was taking away the let's not do this. It was taking away the electrons from the electroscope, and then up to this point here, the electroscope on its own as a whole was neutral because no electrons were going away or coming into the electroscope. We start with a neutral, there is a distribution, and then we implement the grounding, which serve us as a bridge to either remove the electrons or add the electrons into the electroscope. And now when we take the grounding away and we take the, so take the grounding, take grounding away. So this will be the fourth step, but keep the rod, and then as the fifth one, you will have the electroscope without the rod. Take the rod away. What you are leaving the electroscope with is with an absence of, this is the absence of the electrons, because on step 3, implementing the grounding, you removed electrons away from the electroscope. So now the whole electroscope is becoming now less electrons than protons, which means that it's becoming positively charged. So the electroscope is becoming positively charged, and they will have the tendency to go to the leaves because it's the pointy area. So you will have mostly positive, but in between some negatives. Okay. And then the leaves will be again away from each other because they are positive. But remember now, we started with the neutral electroscope, and we placed a negative charged rod, and we ended up with a positively charged electroscope. So the electroscope is charged the opposite of what the rod is. Now, as homework, what you will do is you will see what is happening with the electroscope, starting again with a neutral electroscope. And now, instead of a negatively charged rod, you will put a positively charged rod. So stop the video here and then see what will happen, and I will explain it in this video. So when we have a neutral electroscope, the leaves of the electroscope are parallel to each other. And then this is the first step. We start with a neutral electroscope. And then we add now a positively charged rod. So what is happening when we have a positively charged rod? More negative charges are on the leaves, and this is becoming positively charged. Since the leaves are charged, with the same charge, they will repel each other. And then what we do is we apply grounding. Grounding is simple as touching the knob of the calculator. This is positively charged. So again, grounding serves as a bridge to provide with making the object neutral. So if it has excess of electrons, it takes them away. If it has absence of the electron, provides this. In this case, the knob is positively charged, means that the number of electrons is less than the number of protons. So in order to become neutral, you need more electrons. So this is what grounding is doing, is giving you more electrons. By giving you more electrons, what is happening when you remove the grounding and remove the rod, the whole electroscope is becoming negatively charged, and a redistribution of the charges will happen, making the leaves now negatively charged, even though the rod is not present there. I hope that this makes sense. We will talk about this in class as well. However, this is how you charge the electroscope. Keep in mind that you start with a neutral electroscope, and then you have a positive or a charged rod, and the electroscope will end the opposite of your charged rod. We'll talk about this in class as well.